Okay. All right. We have a problem here. Is motion problem, and it reads: a car starts moving from rest and accelerates uniformly at 3.75 meters per second squared for 16 seconds. The car decelerates uniformly at 5.6 meters per second squared for 5 seconds to attain a steady velocity. It then maintains that velocity for 21 seconds, after which the brakes are applied and the car decelerates uniformly to rest in 8 seconds. Question A reads: draw a velocity time graph to illustrate the motion. Question B reads: calculate the total distance traveled by the car. Question C reads: calculate the total distance traveled after 30 seconds. Question D reads: calculate retardation that brings the car to rest. And question E reads: calculate the average speed traveled by the car. Okay, so to draw a velocity time graph, we need to have V in meters per second on the y-axis and T in seconds on the x-axis. Okay, so, and we should not forget to indicate the zero origin. Okay, now here it says the car starts moving from rest. So if it starts moving from rest, it has to start from origin, and what happens? It accelerates uniformly. Okay, it accelerates at 3.75 meters per second squared, and the duration for the acceleration was 16 seconds. Okay, so after the acceleration, the car decelerates uniformly at 5.6 meters per second squared for 5 seconds. So because it is a deceleration, what is going to happen is the car speed has to reduce. So that is why we have to indicate it with a negative slope like this. Okay, so the deceleration is 5.6 meters per second squared, and it was for 5 seconds. Okay, but if we add it to these 16 seconds, we're going to have 21 seconds total from the beginning of the motion. Okay, so it decelerated uniformly to attain a steady velocity. So which means this is the point it attains a steady velocity. So after that, it attains that steady velocity. So it maintains that steady velocity for a period of 21 seconds. So if you should add it to this 21, we're going to have 42 seconds. All right. So okay, so after that, what happens? The car decelerates uniformly to rest in 8 seconds. So if you add it to 42, we're going to have 50 seconds. So it means the total journey was 50 seconds. Okay, so this is how the velocity time graph is going to be drawn. All right. Okay. 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 I'm just trying to create a space for myself. All right. So if we should look at the graph, we have some important points to complete it. That because we have final velocities like here, let's call it V1, and we have another one here, that is V2. Okay, so using V is equals to U plus AT. So we can say V1 is equals to U1 plus A1 T1. Okay. All right. So for the first event, V1 is equals to U1. So U will be 0 initial velocity plus A. What is the acceleration for the first event is 7.35 meters per second squared, and the time was 16 seconds. This will give 60 meters per second. So instead of having V1, I will just continue and write 60 meters per second. Okay. All right. So we can still use V equals to U plus AT to be able to find the V2. Okay. So which means V2 equals to U2 plus A2 T2. So what is the initial velocity when the body was decelerating? It will be from here. So it means it's 60 meters per second, and this is the final velocity. Okay, it starts decelerating from this point, so it means the initial velocity has to be 60 meters per second. 60 plus, but because it is decelerating, the speed will reduce, and deceleration is a negative acceleration, so we have to say minus 5.6. okay, then multiply by what is the time. The duration for the deceleration was 5 seconds in the second event. Okay, and that will give you 32 meters per second. So I will go on to replace that on the velocity time graph. Okay. 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 So we move to question B, which says the total distance. Question B, the total distance. So to calculate the total distance traveled, we have to analyze the velocity time graph. Okay, so we can realize that there were 4 events here. So, and the distance for them will be S1, S2, S3, and S4. So the sum total of the individual events will give you the total distance. So if you look at the first event, we have 16, we have 60 for S1. So this looks like a triangle. So the area of a triangle, it is what will give us the distance, is half base height. What is the base? The base is 16. What is the height? Is 60. And that will give 480 meters. Okay. So we'll move on to find S2. Okay. And this is how S2 looks like. Okay, if we go and analyze it, sorry, I should draw it correctly. All right. The way S2 is represented, actually, this is how it is. Okay, S2, we have, if you look at it, we have 32 here, we have 60 here. All right, so, and then we have 5 here. Okay, so because that is the point from 16 seconds to 21 seconds, the difference is 5. Okay, in fact, the deceleration took 5 seconds from the question, we know that. So to find the area of a trapezium, because it looks like a trapezium, the area of a trapezium is half A plus BH. where this side will be A, this side will be B, and this will be H. So that will be half into A is 32, B is 60, H is 5. That will give you 230 meters. Okay, so if we should find S3, S3 looks like a rectangle, sort of. Okay, S3, and then what do we have? We have 21 here. Okay, how did we get that? If we look at the point between 21 and 42, if you find the difference, it is 21. Okay, and the height is 32. Okay, so S3 is equals to the length times the height. That's the area of a rectangle. So that will be 21. What was the height is 32 here. Okay, so that will be 21 times 32, and that will give you 672 meters. Okay, finally we have a triangle for S4. This side is 32 and this is 8. Okay, so the area of a triangle is half the base times the height. So this will be half, the base is 8 and the height is 32. And what do we get from that? We have 128 meters. So if you look at it, we'll have the total distance will be S1 plus S2 plus S3 plus S4. This will be 480 plus 230 plus 672 plus 128, and that will give me 1510 meters, 1510 meters. So that is question B. Okay, it says calculate the total distance traveled. Okay, then the next question is calculate the distance traveled after 9 seconds, after 30 seconds. Okay, now if you look at the graph, where will the 30 seconds fall? Okay, it will be somewhere between 21 seconds and 42 seconds. Let's assume this is where we have 30 seconds. Okay, so it asks us to find the total distance traveled after 30 seconds. So if this is 21, how much or how many seconds do I need to give me 30? That is when, because that is the body was at what? It was maintaining a steady velocity. So that will give 9 seconds, right? It has to be 9 seconds from here. Okay, so which means this period is 9 seconds. So I already know distance 1, I already know distance 2. So it means I only need to know the distance traveled while the car was maintaining a steady velocity for 9 seconds. So that will, if you look at it, it looks like a rectangle sort of. So where the base will be 9 and the height will be 32 seconds. So should I draw that? That is question C, right? Okay, that is question C. For the question C, If I have 9 seconds here, I have 32 seconds. I can find the area, okay? So let's call it distance.